So just very, very quickly, we're a consulting firm. We're hired by companies who are looking to transform their environment from traditional methods of analyzing data to some of the new emerging modern data engineering techniques and technologies. We've been in business for about 15 years, won lots of awards. We're pretty small. I am the president. This is the chief architect. We are involved in most projects that we deal with, if not all projects. We're not one of the big monolithic companies where our clients are like a blip on their radar. Our clients are very, very important to us, and we actually get to pick and choose exactly what type of projects we do. We don't just say yes to everyone, because we are definitely geeks at heart, and we like to have exciting projects. And also, the reason we picked this particular one is because not only am I a geek, but I'm also a musician. So the music industry is something, if I know, the two things I know most about in the world, data and music. So I've been studying music since I'm 14 years old and been playing in bands my entire life. And actually, I should not even be here because I was booked to be on this cruise that's actually out to sea right now. So I wore a Motorhead t-shirt just to honor where I really should be. And also the day the boat left was my birthday, so even more. But the reason I am here is because at heart, I am a geek. So if I had my choice, I'd much rather be here. And I think what we did is actually really special. And I think hopefully at least one person in the room will learn something from it, and then it's all worthwhile. So, since I've been a child, I've been listening to music and playing music. And through the 70s and 80s and some of the 90s, usually my history was like buying probably 4 albums a week from the time I got my very first job. And over the course of time, and this is overall, this is not just me, overall the entire industry has really been turned on its head a few times. But nothing like it's been turned on its head lately. And what's happened is that, all of us are tech geeks, I think, in the room, or for the most part, or at least would like to be. And the last few years, I've been doing this about 30 years, the last 2 years have been really, really disruptive and exciting. But from what we do is nothing compared to what the music industry is experiencing. Like everything that they do, and they've been doing it for a really long time, decades and decades, it's completely turned on its head. Right, the thought of having a business where you produce an artist and make a product and then go out and sell it and then send distribution and push out your records and make sales, that really has changed. It doesn't work like that anymore. So what's really been happening, and also the notion of selling an album at a time, completely different, doesn't really work anymore. So the music industry has transitioned from selling widgets, which happen to be music albums, to actually becoming technology companies, right? Where they actually have to be very, very sophisticated, being able to capture a lot of data from all different avenues. So what we've been seeing over the past couple of years is that there actually has been a level. It went from a huge spike in digital downloads, right? And buying buying songs one at a time. It's actually leveled off a little bit, and now all we're really seeing in the industry is just music streaming. I personally have not bought a piece of music in probably 2 years, and I'm probably one of the most diehard music buyers that there possibly was. And it's a very, very different way of thinking about music. One thing another anecdote. In 1982, I went to go see Black Sabbath for $14.50. I bought tickets about 2 weeks ago. It was $149. And the paradigm has actually shifted that the music industry used to go do concerts to sell albums, right? It was like promoting your albums. Nowadays, people are streaming music for free so that people go see them live. It's really changed the paradigm a lot. So having data is really, really important, and understanding all of those streams is really, really, really important, because now as a music company, who do you invest in to send on tour? The only way to know if actually people are going to show up at the concerts and buy tickets is if you can actually analyze your streams right? So streaming data and streaming analytics is more crucial than it's ever been. So the reason we actually got involved is because, you know, for like healthcare and banking, there's standards on how to transmit data. You know, you have HL7 standards and FIX, which is Financial Information Exchange Protocols. In the music industry, there really are no standards. So, and the other thing that's crazy about the music industry is that most of these companies that are streaming music, they're being born every day, right? One I just added just yesterday, still in beta, and that's that one. But the other thing is they're mostly startups, right? So they're actually making some of this stuff up as they go along. So the music companies have to be able to ingest this data as it's changing under their feet, right? So we needed something that was very, very dynamic, easy to ingest data and make sense of it. So, you know, one approach is, oh, you're dealing with unstructured data, just forklift everything that you do and put it into Hadoop. That really was not the answer. Hadoop was definitely part of the equation, but just putting things in Hadoop does not solve your problem, right? Putting things in Hadoop is a start of the solution. What the real solution was changing how we think about data, how we think about, you know, instead of like structuring it to analyze it, we need to be able to just ingest it and start analyzing it right away. So we needed to build a dynamic framework so that we can ingest data in any format, unknowing to what it was, data that we've never experienced before, and be able to enable analytics as quickly as we're ingesting it, or nearly as quickly as we're ingesting it.
So our requirement was to build a dynamic platform. And this is a platform that needed to be dynamic, not just in how you ingest data and you process data, but also dynamic in that we really needed to break from kind of fixed capacity and traditional kind of infrastructure computing. So in the old days, one of the biggest paradigm shifts is kind of the way that we ingest and process data. So we started out by interrogating data, figuring out how we wanted to structure it, then do a lot of development, and then when all that was done, we'd ingest it and we'd analyzed it. So now we kind of reverse that equation. We ingest the data first, we produce analytics, we streamline our path to analytics, and then provide a more agile environment for downstream applications that require structure. In terms of fixed capacity, we've gone from, you know, provisioning for the high watermark to building a completely dynamic cloud-based infrastructure. And finally, in terms of technologies, you know, very often when you're building a platform, you think about a specific back end and a specific set of technologies, and it's probably gonna be tightly coupled. We thought about this problem more as an ecosystem. So we'd have a diverse set of technologies that have different strengths for certain types of problems, certain types of storage, and then you know, using that as a platform to also adopt new technologies as they became available, like Apache Spark. So our recipe was cloud, modern data lake, and this concept of the polyglot warehouse, and we're going to talk about these.
So moving to the cloud, one of the first challenges that we had was, you know, when we would receive streaming data from some of the providers, we had really no idea how much data we were going to receive. You know, there were certain thresholds that we would set, and then they'd always be either exceeded or way below. You know, those of you who are Bruno Mars fans and you know the song Uptown Funk, that actually broke records for having over 15 million streams in a single week. So, you know, that's probably more than all the other streams combined from all the other artists. So, you know, the notion of trying to do that on fixed capacity is just, it's out of the question. We just can't do that. So we needed to move to the cloud. We needed also, by putting it out on AWS is the solution we used, putting it out on AWS, the business of actually maintaining your clusters and administering Hadoop and handling the operations really is removed. We can actually start focusing on the solution rather than the administration of the infrastructure. So we decreased the complexity of the infrastructure, really removed it from what we actually needed to do, and we were able to focus more on the business. You know, also what it did is every time we would onboard a new provider, it would be a new upfront cost, new servers, blah, 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 new processing power. We didn't really need to do that. We could just spin up clusters and spin down clusters as we needed them. Elasticity was really the biggest, most powerful thing for us. This is just a visual of what was happening. So, you know, you have to really expect, you know, the highest watermark when you're purchasing servers. Otherwise, you run out of space, you're out of business. So you always tend to overbuy. When we moved to an elastic environment, we were able to actually make it part of the application that we would spin up processing power as we needed it and spin it back down when we didn't need it. The other biggest benefit was, you know, not only do you reduce costs by not having to make upfront investments, but you really, without the elasticity of being able to very easily scale up, then you're out of business, right? Once you run out of processing power, you can no longer process your data and the lights go out.
So, kind of strong words, but I think, you know, managing infrastructure is not a happy thing. You know, the first wave of kind of cloud adoption is really renting servers, you know, so not that much different than what you do if you manage the servers yourself or you have them set up in some colo. The concept which we promoted was really thinking about our interactions with servers to be API calls. So we never want to SSH into a server if we can avoid it. We want to think about servers as kind of like objects or resources. We don't want to think about them as these tangible boxes that are floating somewhere, virtual or not. You know, we really just want to abstract them out. We want to have simple and stateless processes as much as possible. So if servers go away and we have to spin up new servers, there's not this question of where the data is and where it's being preserved. Additionally, we have this goal of being ephemeral. So if at all possible, we don't want to manage any servers. So we don't want to care about any servers. We don't want to worry about them being up. We don't want them to be up for extended periods of time. And we want replacement of resources that fail to be very easy. And finally, we want to make everything scalable and elastic. So what do we mean by ephemeral? Really what we want to do is build processes where the resources are kind of temporary. You know, so in our environment, we employed three kind of ephemeral resources. This concept of processing fleets, which we'll talk a little bit about, elastic MapReduce clusters, and also ephemeral Redshift clusters. And for those of you who have been playing with Redshift, we've been experimenting with using Redshifts ephemerally as little analytic clusters for data scientists and analysts, but also for ETL payloads. Really, we don't want any server to live any longer than its usefulness. So if we have a job to do, we want it to process a job, be terminated at the end of the job, and the capacity, you know, essentially managed that way for cost savings and otherwise. And in order to have this kind of architecture, we use distributed services such as Cassandra, Dynamo, and S3 to preserve state. So all of our processing is temporary, doesn't really have you know, any data to hold on to, and we manage it outward in shared distributed services. So just in case you guys have not dealt with this paradigm, this is a processing fleet. So a lot of the data that we got was trickled in throughout the day. You know, so files and providers would be dumping data out to our systems on an hourly basis or intraday. This data would be ingested into S3. So S3 was where all the data ended up. This was our data lake. So when that happened, we would queue these processing units, these files, these records, which would be put out on S3 in a queuing service, and then we'd have this elastic fleet fleets of EC2 instances, which would pick up the work, write the data out to S3, as well as Cassandra, which was used for revenue recognition processes as well as analytics. So we'd keep an eye on the queue. As we had a backlog, we would add more servers dynamically and deploy our code for that specific instance. And if the queue is at zeros, we would scale all the way down to one instance, you know, in a lot of cases. So therefore, essentially only having as many servers as we needed to complete a specific job. We also used elastic MapReduce. So as Joe said, Hadoop was part of the equation. However, we did not want to manage a Hadoop cluster from an operations perspective. So we essentially developed this framework. that would provision a cluster, deploy our code, run a job, and terminate the cluster when it was done. We would essentially bootstrap it with the processing engine that made sense. Most of our initial work was done in Hive and Pig, high-level MapReduce processing languages, although almost all of our new work is done in Spark. And additionally, we're piloting new technologies all the time. So trying out Impala for certain processes, as well as even Presto. So another thing that we did is we started out by provisioning 20 CC3 EC2 instances for all of our MapReduce clusters. So we developed essentially some pretty simple algorithms that, based on history, as well as input size, to more effectively estimate what sort of a cluster we should build. So it's not scientific, not purpose, but we were able to reduce the EMR costs as well as unused capacity in our processes. And finally, we did need some persistent servers. In the end, we had a footprint of about 24 persistent servers. The rest of the infrastructure was ephemeral. The high watermark of a permanent infrastructure would have been several hundred, so I think that's pretty reasonable that we had a couple dozen servers. The two technologies which stuck around were Cassandra. We had an existing footprint of Cassandra in the organization. We really liked Cassandra because of its multi-AZ, multi-region capabilities, as well as vNodes, which gave us the capability for easy elasticity. And then, of course, Redshift, which, although not as elastic as other services, you can actually grow it out, and shrink it down with some careful planning. So we really fell in love with the service and use it for both ephemeral processes as well as a persistent large data warehouse.
So Elliott alluded to a data lake, and we know that data lakes are probably as ambiguous, if not way more ambiguous, than a data warehouse. Our history is building data warehouses, and we go to a lot of clients and they say, we ask, do you have a data warehouse? And they say, yeah, we have Cognos. That's not a data warehouse. And I think there's as much confusion, that's evened out over the last couple of years, but now what exactly is a data lake? We're going to talk about exactly what we built here, and typically it's no different from what we build in most places. So, it includes scalable distributed storage. In this case, we use S3. And also, we use EMR so that we can scale up and down very, very easy, fit-for-purpose processing. What this enabled was us to really eliminate all of the barriers between the data and the users, and the heavy-handed restructuring of data that's typically handled by IT before users are allowed to have at it. Right, so this really empowers the data science team, if you have a data science team, or even just deep technologists and deep analysts who are actually, cannot get in too much trouble handling data that's not fully governed, right? And the beautiful thing about this pretty eloquent solution is that we actually are fully governed when it matters, and what we're going to talk about in the next slide is exactly how do we handle governance, which is, when you're dealing with startups and data and solutions where, it's basically just running your application and it's not a large enterprise, it's not as important. But when you're dealing with enterprises and big monolithic companies, data governance is probably the most important thing, and probably one of the barriers for why big data is not getting adopted even quicker than it is today. So what we did is we came up with this paradigm, actually Elliott invented this paradigm, of actually having a tiered, layered process of dealing with our data. And the first one is just purely for landing, right? Bring it into S3, full fidelity. As we're receiving these logs and these streams, we just actually sit it down on disk. And then we as a company and most of our clients who we deal with, that to us is not the data lake yet. It's part of the ecosystem of the lake, but it's not really the lake. What we consider the lake is once we start enriching that data. So what we do is we actually start organizing it, defining it, and applying some of the data governance capabilities that are required before users can actually have at the data. So we start applying data governance and monitoring and metadata, information lifecycle management, so that we know, when data is going dormant, if we could drop it or not, and allow users to actually create data as they need it. apply security, and have a data catalog so that people can actually find data when they actually need it as well, and not keep recreating the same data sets. And then from there, the data science workspace is really for data scientists to actually, it's their sandbox. They can actually do whatever they really want to do in there. And that's where they're actually doing machine learning, creating insight, customer scoring, figuring out if artists are actually profitable, doing munging data, comparing it against marketing data. And then from there, we actually graduate the data into the big data warehouse. In this case, it was Redshift. Other cases, it could be back on your data warehouse appliance like Netezza, whatever floats your boat when it comes to data appliances. But this was a completely AWS solution. We are seeing much, much more AWS in the market space. I'd say 50% of our solutions this year are AWS. This was perfect fit for this one. And then once it's in the big data warehouse, then it is fully governed, and that's when you can put traditional BI tools on top of it and let the masses have at it. Right? So the data lake has all of the data that's coming in from the source, and it also is enriched with context with data coming in from your data warehouse and from other systems. And that is the pyramid. Anything to add?
No.
No, that's it. Okay. So just this one.
I can take that one.
Yeah.
So about that landing area and how we ingested data. So we leveraged S3 just because it provided us a lot of services. In fact, the way that that S3 was essentially presented to users was through a lightweight API that we just wrapped a lot of native S3 services and methods. So we provided a lightweight API wrapper, which would essentially allow them to bring in data throughout the day, a web front end for companies that just wanted to upload data in bulk, and certain of our high volume customers would have direct write access to certain buckets within S3. So the data requirements for getting data into S3 were actually very low. We just needed to organize the data in a reasonable partitioning schema for both data management as well as performance. But other than that, we did very little other than ingest data. And really the goal here is to be able to turn the data scientists and the analysts loose, but furthermore, to streamline the process of getting that to the cash register in terms of revenue recognition, as well as our analytics and decision support systems.
I do want to go back to this one when you talk about late bind.
Yeah, so late bind. So really the promise here is being able to analyze data and work with data without doing much work. So what we really see is that the data lake is more of a virtual concept. So it really means that you provided a governed kind of integration point, whether it be a table, like a Hive table, as well as data quality and data quality monitoring, which we're going to talk to in a bit. So making sure that the data is right, because as we said, a lot of these companies are startups. We don't manufacture this data ourselves. It's very hard to provide guarantees on what we're producing and ingesting into the system, and it's very bad to be wrong. So this is more in service of this. We do need to feed the cash register, so this is moving up the stack in the pyramid. So data needs to be refined in Map. We use our processing fleet, we use our EMR. And then what we try to do is take development out of the equation as much as possible. And this is just a good general rule. We try to avoid development 80% of the time and make it metadata driven. Approaching 95% is extremely dangerous because then you end up building a battleship which becomes more cumbersome than actually doing custom development. And when we do custom development, we try to abstract away the big data. We use high-level languages. We're definitely using a lot of Spark. We're finding that extremely productive for starting out with analytics and then moving into processes which move data up the stack, up the pyramid. And then finally, we need to make sure data is right. So we found it critical to develop automated data quality checks. And we actually developed a little tool called HAMBot. HAM stands for Health and Monitoring, which essentially does data quality checks, domain level assertions on the data so that we can be confident when we present this data in the data lake and elevate it to some of our analytics systems, including the data warehouse, that the data is correct. And we should be open sourcing this soon. It's a little intuit right now, but we're hoping by early next year that we can open source this so other people can take advantage of it as well.
And just a little note on Hambot. So Hambot, the specs for Hambot is actually come straight out of the book that I wrote 15 years ago about how to automate data quality and make a subsystem for all of your ingestion and your processing. And all we did is really adopt what used to be mostly SQL based, and we made it so that you can run your data quality screens in any language you want. Mostly in this project, we use mostly Python. So, you know, one takeaway that we'd like everyone to get out of this is the thought of, you know, not thinking about technology stacks anymore. You know, our business used to be almost probably 80% Oracle. Sorry, Philip. But we have, you know, and then the rest of it, the balancing was probably SQL Server, DB2, some other RDBMS. We haven't really done a new data warehouse solution or any kind of analytics platform on an Oracle infrastructure in probably 2 years, probably 3 years at this point. So what we're finding now is that really just understanding what are the use cases and what are the design patterns that we actually need, and then having enough knowledge and expertise with all of the products that are available and just getting the right tool for the job. And that really, and then figuring out how it all works together is what creates the ecosystem that breathes life into your business. So in practice, what we're typically doing is taking new technologies, modern data engineering and emerging products, and we're just applying a lot of the same rules that we've been doing for the last 20 years. But we're doing it, you know, using slightly different methods and absolutely all new technologies. So the thought of actually consolidating your data so that you could provide analytics and doing data governance, and the notion of having data that is not fully governed, but being able to govern it just enough and just in time so that users can have it very, very early on. One of the biggest challenges before we started working on this project was that allowing users to actually analyze their artists was not only a technical challenge, but it was also a political challenge of being able to have out the data before it was like, you know, thumbs up from the data governance organization. So, you know, it takes some technology shifting, definitely a paradigm shift within your IT organization, but also culturally about the way you run your business. We definitely had to help with the adoption and embracing the different ways of thinking about your data. You know, understanding that the days of actually owning your data and understanding it and structuring it, profiling it before you can release it to anyone, those days are behind us, they're over, right? Everyone in this room, for the most part, if not today, very, very shortly, you'll be experiencing data that you've never experienced before, and not knowing like if it's gonna have any value or not. So analytics has to come first. So we needed some kind of new paradigm to actually enable the new way of handling data. And hopefully that this actually helps explain how to actually do that.
So finally, this is the big picture. So this is what it looked like in the end. So as stated, we had a bunch of data providers providing data through our lightweight API, as well as on the other side of the house, we actually had social media coming in. In fact, a full Twitter fire hose. This was ingested into an S3 data lake. We processed the data using our near real-time, using our processing fleet, as well as these ephemeral EMR clusters. The EMR clusters bridged both, you know, kind of our standard processes as well as data science, and everything was integrated with a central external Hive metastore. So all of our data sets appeared in Hive and were shared in a central RDS. So the products of this would go into Cassandra, which backed our revenue recognition process, which is the cash register, as well as analytic tools such as our artist dashboard and some other decision support systems which were used by marketing and operations. On the bottom half, we have kind of our analytic environment again. Data science, having the ability to spin up Redshift clusters, the ability to spin up EMR in the context of metadata, and access to data through the Hive Metastore. A pretty large Redshift data warehouse, as well as several graph applications.
And just to state the obvious, in case you didn't notice, the rectangle in the middle is exactly the data pyramid that we introduced earlier. It's actually upside down, just for the ease of the slide here. But you know, getting data through the landing area, doing late bind for analytics to support the data science team, and then moving it to Redshift for the data warehouse. And eventually, on the data warehouse, you can use simple tools like Tableau. On the right-hand side, it was custom-made applications, you know, and really common for us to use things like the W3 libraries, not W3, D3 libraries for visualization. And interaction with your data, not only just receiving it as a consumer, but actually interacting with your data on the data lake is the new shift, and it was absolute requirement in this scenario as well. And that's it. You know, just one thing that we'd like to take away, that, you know, the data itself, everyone has data. This project definitely had lots of data, but the data itself is not as important as what you're actually doing with your data. So if you'd like to talk to us, we are actually going to move out so the next people can the next speaker could set up. We'll hang out outside. We'll loiter in the hallways for a while. If you want to come talk to us, we'd be happy to talk to you. Thank you.